For today's video, I'll be discussing to you about rules of inference under the topic mathematical logic. By the way, I am Charlene Joyce F. Malinao and I'll be reporting to you this topic, and I hope that you'll get something or learn something from it. So let's get started. To deduce new statements from the statements whose truth that we already know, rules of inference is used. When we say inference, it is a conclusion reached on the basis of evidence and reasoning. And this topic, there are terms that we need to remember. We know that mathematical logic is often used for logical proofs, and these proofs are valid arguments that determine the truth values of mathematical statements. And an argument is a sequence of statements that must be correct and complete, because correctness prevents us from fooling ourselves and completeness allows anyone to verify the result. The last statement is the conclusion, and all its preceding statements are called premises or hypotheses. And this symbol is read therefore, and it is placed before the conclusion. A valid argument is one where the conclusion follows from the truth values of the premises. Rules of inference provide the templates or guidelines for constructing valid arguments from the statements that we already have. And these are addition, conjunction, simplification, modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, constructive dilemma, and lastly, the destructive dilemma rule. First up is the addition. If P is a premise, we can use addition rule to derive P or Q. Say for example, let P, he studies very hard. So in this rule, he studies very hard is our P. So therefore, either he studies very hard or he is a very bad student. That's our conclusion. Where Q is the proposition, he is a very bad student. The next rule is the conjunction. So in conjunction rule, if P if P and Q are two premises, we can use conjunction rule to derive P and Q. Let's have an example. Let P, he studies very hard. Let Q, he is the best boy in the class. So in this rule, he studies very hard is our P. And our second premise, he is the best boy in the class, which is our Q. So therefore, he studies very hard and he is the best boy in the class. P and Q. The next is the simplification. If P and Q is the premise, we can derive P in this rule. And let's have an example. Let P, he studies very hard. Let Q, he is the best boy in the class. He studies very hard and he is the best boy in the class. That's our premise, P and Q. Therefore, he studies very hard, which is our P. Next rule, modus ponens. If P then Q and P are two premises, we can derive with the use of this rule, modus ponens, Q. Therefore, Q. Let's have an example. Let P, you have a password. Let Q, you can log on to Facebook. If you have a password, then you can log on to Facebook. That is our P, then Q. Second premise, you have a password. Therefore, you can log on to Facebook. That's so simple. The next is the modus tollens. If P then Q and negation of Q are our premises, we can derive negation of P with the use of this rule. Say for example, let P, you have a password. Let Q, you can log on to Facebook. If you have a password, then you can log on to Facebook. That is our P, then Q. You cannot log on to Facebook. That is our negation Q. Therefore, you do not have a password. Negation of P. Next is the disjunctive syllogism. If negation P and P or Q is our two premises, we can derive Q with the use of this rule. Say for example, let P, the ice cream is vanilla flavored. Let Q, the ice cream is chocolate flavored. So the ice cream is not vanilla flavored is our negation P. And the ice cream is either vanilla flavored or chocolate flavored or P or Q. So we can derive, therefore, the ice cream is chocolate flavored, which is our Q. The next rule is the hypothetical syllogism. If P then Q and Q then R are our two premises, we can derive P then R with the use of this rule. Say for example, let P it rains, let Q I shall not go to school, let R I won't need to do homework. If it rains, I shall not go to school. That's it. That's our P then Q. If I don't go to school, I won't need to do homework. That's our Q then R. Therefore, if it rains, I won't need to do homework. That's R. Therefore, P then R. The next is the constructive dilemma. If P then Q and R then S, and P or R are our two premises, we can derive Q or S. For example, let P it rains. Let Q I will take a leave. Let R it is hot outside. And let S I will go for a shower. If it rains, I will take a leave. And if it is hot outside, I will go for a shower. And that's our first premise. Either it will rain or it is hot outside. Our second premise. Therefore, I will take a leave or I will go for a shower. That's our conclusion. The last but not the least, the destructive dilemma. If P then Q and R then S, and negation of Q or negation of S are our two premises, we can derive negation of P or negation of R. Say for example, let P it rains, let Q I will take a leave, let R it is hot outside, and let S I will go for a shower. If it rains, I will take a leave, and if it is hot outside, I will go for a shower. That's our first premise. Either I will not take a leave or I will not go for a shower. Our second premise. Therefore, either it does not rain or it is not hot outside. And that's our conclusion. So, those are the 9 templates or guidelines of the rules of inference. And I want to challenge you to answer these exercises. It has 6 items, all in all, and I want you to answer it on the comment box below to see if it is right or wrong so I can correct it. And that ends my report. If you have any questions or clarifications, you can also comment it on the comment box below. And I hope that you have learned something. And thank you for listening. Goodbye and God bless.